morning, this is K Devender Reddy, Assistant Professor in Institute of Aeronautical Engineering, EEE Department. Today I am going to teach introduction and constructional features of induction motor. As we know, induction motor is basically a rotating machine. So we can use the induction machine either to convert mechanical energy into electrical energy or electrical to mechanical and mechanical to electrical energy. So constructional wise, it is very similar. It is very similar to the DC machines, and all the rotating machines are constructionally very similar. And it is very similar to the transformer. Like a transformer, it is a singly excited machine. Three-phase induction motor also a singly excited machine. Stator of three-phase induction motor is connected to a balanced three-phase AC supply. It can produce rotating magnetic field in the stator bars. And according to the speed of the rotor, we can use the induction machine as generator as well as the motor. If the speed of the rotor is greater than the speed of the synchronous speed of the rotating magnetic field, then the machine will be act like a induction generator. If the speed of the rotor is less than the synchronous speed of the revolving magnetic field, the machine will be acts like a induction motor. Coming to the construction part, in the construction we should focus first of all on the stator parts. The stator of an induction motor consists of the following parts: stator frame, stator core, and the type of the slots in the stator core, type of the polyphase winding, whether it may be distributed or concentrated, end covers, and bearings. See here the complete view of three-phase induction motor, and here this is frame, that is we can also call as a yoke of the three-phase induction motor, and this is rotor, two end covers, front end side and back end side, bearings, terminal box, base, and cooling fan. So in this video we should focus first of all on stator construction. Generally, the stator frame is made up of cast iron. It serves the following distinct purposes. It acts like a mechanical support. It provides a mechanical support to the stator core, and it acts like a protecting cover for the stator winding and all the rotating machine parts inside the stator frame, and it gives a mechanical support to the core, and it is not designed to carry the magnetic flux like DC motors. Stator core. Generally, the stator core is made up of high-grade alloy steel, that is called as silicon steel. Generally, we prefer with the proper laminations. The laminations of the stator core generally varies the thickness of 0.35 mm to 0.65 mm thickness, and the thickness of the lamination is depending upon the frequency of the supply we are connected to the stator. Generally, the thickness of the laminations are inversely proportional to the frequency of the winding supply, and each of the laminations are insulated each other with a paper insulator. or any of the insulating medium we can use to insulate the laminations. So laminations are very useful. Means it is required to reduce the eddy current losses in the stator core. And these laminations are stamped under hydraulic pressure, and it forms a stator core. And the stator core is also provide housing for holding the stator winding. So the stator core have the three different types of the slots, that is open type slot, semi-closed type slots, and the closed type slots. And these three have their own advantages and disadvantages. And these three type of these slots are um, used in a different types of the machines. Generally, semi-closed type slots are used in three-phase induction motors, whereas in the case of the uh, DC machines, open type of the slots, whereas in the case of the single-phase machines, closed types of slots we are using generally because of their own advantages and disadvantages according to the requirements of the type of the machine. We choose one of the type of the slots. So, for example, first open type slot. So this is a open type slot. It has quite decent advantages, easy to access the winding without any problem, and also we can easily access the farmer windings in the slots if it is a double layer winding or a multi-layer winding. And it produces very less leakage reactance. So the leakage flux is less means your winding reactance, inductive reactance of the winding also reduces. So leakage flux is nothing but the flux which not links both the windings, that is a stator and rotor magnetic circuits. It links only the stator one, we can call it as a leakage flux. If it links both the windings, means stator and rotor, we can call it as mutual flux. So the leakage flux, less leakage flux means less leakage reactance. The inductive reactance of the winding, stator winding, is very less. So if the inductive reactance of the winding is less, so your impedance is less. So impedance of the winding will reduces. So no load current is more. The disadvantages of the open type of the slots: the wide opening of the slots. Due to the wide opening of a slots, average air gap length is more. So obviously air gap length is increases, reluctance offered to the magnetic field between the stator and rotor is also more. If the reluctance is more, more excitation current is required, and the power factor is very poor. The air gap flux distribution is also non-uniform in the case of the open type slabs. Due to non-uniform flux distribution, harmonic torques will come into the picture. Due to the harmonic torques, these harmonic torques causes several vibrations and more noise in the machine operation as well. Semi-closed slots. Advantage of the semi-closed slots. So here we can see semi-closed slots. Because of the narrow opening of the slots, flux distribution is uniform. So the uniform flux distribution and narrow opening of the slots. So basically the reluctance, average air gap length is decreases. So reluctance also decreases. Reluctance to the stator and rotor magnetic circuit. It's, sorry. Reluctance of the air gap is less compared to the open type slabs. So the magnetic leakage is also less. So less magnetizing current is required and a better power factor will come into the picture in case of the semi-closed slats. Disadvantages of the semi-closed slats: access of the slats is very difficult, and access of the farmer windings is also very difficult. It offers high leakage reactance to the windings. Closed slots. So advantage of the closed slots: average air gap length is minimum, so excitation current required also minimum, and the power factor also increases, and improved no load current. Flux distribution is uniform, so air gap length is minimum, so the flux to distribution is uniform. So due to the uniform flux distribution in the air gap, no harmonic fluxes are coming to the picture, no harmonic torques are coming to the picture. So because of the harmonic torques are eliminated from the machine, smooth operation is possible compared to the other two types of the slots. Disadvantage of the closed type slots: access of windings is very difficult, and access of farmer windings is also very difficult. Leakage reactance is very high. So you can see here the comparison table for open slots, semi-closed slots, and closed slots in the different aspects like a magnetizing current, no load power factor, input power factor, leakage reactance, maximum torque produced, and starting torque developed, harmonic torque, that harmonic torques developed in induction machine. So first compare magnetization current, that is a magnetizing current for induction motor. Open type slots required more magnetizing current than semi-closed as well as the closed type slots. So see the relation here, I mu magnetizing current is greater than semi-closed and also greater than closed type slots. No load power factor, no load power factor, open type slots no load power factor is very less compared to the remaining two types. So no load power factor is, we can name as cos phi naught, is less than no load power factor of the semi-closed slots, and it is also less than the closed slots. Input power factor, naming as cos phi 1, it is also less in the open type slots, cos phi 1 less than cos phi 1 of the semi-closed slots, and also less than the closed slots. Leakage reactance, leakage reactance of the open type slots is less compared to the other two types, semi-closed and closed types. XL less than, leakage reactance of the open type slots are less than the semi-closed and closed types. Maximum torque developed in open type slots is greater than the remaining two types, that is semi-closed and closed type. Tmax greater than the Tmax of semi-closed as well as the Tmax of closed type slots. Starting torque in open type slots are less compared to the remaining two types. T starting starting torque of the open type slots are less than the starting. Starting torque of open type slots are greater than the starting torque of the remaining two types. TST is greater than the semi-closed type and also greater than the closed type slots. Harmonic torques produced in the induction machine in open type slots are greater than the remaining two types. So by the comparison of three type of the slots, open type slots, semi-closed and closed type slots, generally in the three-phase induction machines, semi-closed type slots are preferable because it has a partial advantage of the closed type as well as the open type slots. Whereas in the case of the DC machines, open type slots are preferred, whereas in the case of the single phase machines, closed type slots are preferred to limit the starting current in single phase machines. And the characteristics point of view, induction motor have very similar characteristics like a DC shunt motor. So in this video, we discussed the introduction part of the three-phase induction motor and the constructional feature of the induction motor, that is up to the stator construction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.